Power. Everyone wants it. And that goes double for data centers, which are the vertebrae of today's digital infrastructure. According to studies done by JLL, data centers account for 2% of the global energy consumption in 2025. In addition, the total global energy demand is also expected to double in the next 5 years to about 100 gigawatts.
The first world's voracious appetite for data. We are firmly in the fourth industrial revolution where data has become our currency. It's replaced money, right? This is what we trade back and forth every day. Whatever company now has in their value proposition. So as our cultural appetite continues to increase for data and the services that that data provides, data center owner operators have to build more, and it's not abating. It's increasing actually every generation. If you have kids of any age, you will see this. They use data services and data centers way more than we did at the same age. So data center owner operators have to keep up with this demand. It's become part of their value stream. And if you look at the top 10 largest companies in the world, they're dominated by data center companies: Google, Microsoft, Meta, AWS, and so on. So these companies make their revenue streams by building more data centers to support all this data. So they're keeping up with this cultural demand.
With demands increasing, competition for power will also rise, putting more pressure on an already strained power grid. What's more, with the potential for power outages due to severe weather conditions and changing climates, power reliability will be ever more important. If data centers can't reliably source power from the traditional grid, digital infrastructure may face momentary disruptions or worse, extended periods of downtime. Ensuring reliable power is key to maintaining a data center's uptime. As such, solutions are being developed specifically for this purpose. There is one solution that actually extends back over 100 years to when electrification began: self generation.
The ability to provide your own power becomes a kind of a holy grail for these hyperscale builders. If you can do that and not have to find power in the grid, you can build wherever you want. So there's been a tremendous amount of research and money now in power self-generation. So primary power, instead of connecting to the grid, you make your own power, which it's interesting because 100 years ago or so, when electrification began, that was the original model. Power production was done privately. We may go back to a primary power private generation model using some of these natural gas technologies. They're very hopeful right now, turbines and linear generators and otherwise fuel cells. We may go back to that model if that happens and we can generate power privately for a primary connection.
If that is implemented, then the traditional power grid becomes secondary or even goes away altogether for data centers. That's just one possible solution, though, as another developing technology is a small modular reactor, or SMR for short. According to the International Atomic Energy Agency, SMRs are advanced nuclear reactors which have a power capacity of up to 300 megawatts per unit. That is roughly one third of the generating capacity of traditional nuclear power reactors. They are also inherently modular, allowing for systems and components to be put together in a factory and transported as a unit to wherever they're being installed.
The general thought was this is a technology 5, 7, 10 years away at mass commercialization levels. That may change. If it does change, you will see an immense amount of capital deployed into this technology because, one, it solves for primary power. If you have a small nuclear reactor, you can generate your own power, lowers the reliance on the grid. Grid can be secondary or not present at all. You can deploy in any geography that you like. You have incredible sustainability from a carbon footprint perspective, incredible sustainability impact as well. So that's really, really exciting.
Now, this next solution isn't even a technological advancement. Rather, it's more of a new way of looking at data centers. Essentially, it involves taking an old property like a shopping mall or steel plant and using its already deployed power to create smaller, more compact deployment units. What it ends up creating is a smaller scale data center.
That is a new architecture driven by the industry leader in this space, NVIDIA, because we're moving from one phase of AI, learning or teaching, to the next phase, which is insights or what we call inferencing, where we start to monetize all the teaching and training we've been doing, all the data we've been crunching into big data sets. we're now starting to pull information out of those data sets. It's called inferencing to make money and sell that. Every single enterprise company in the world will need this because of the way the technology works. They will need it close to where their use case is and their customers are.
With this new architectural style being driven by companies like NVIDIA, it may drive organizations to reuse real estate for its already deployed and connected power. In turn, this could have some sustainability benefits, allow for a faster time for deployment, and create an overall reduction of net new energy deployment. The rate of innovation is explosive in the digital age, and it shows no signs of slowing down or stopping thanks to AI. The question is, will there be enough to accommodate all of it?
In the data center world, we've been doing things the same way, particularly operations for the last 25 years. Along came AI, which is a completely new way of doing storage and servers and networking, which forced us to really change things. Our cooling is completely different. AI requires liquid cooling. Our power density is completely different. And now NVIDIA is telling us that our deployment size is shrinking. So to accommodate innovation, we have to creatively destroy the practices of the past in a relatively short period of time. And behind that, we've got the most innovative companies in the world: Microsoft, Google, Meta, AWS, big colocation providers like CyrusOne, who have dedicated a lot of research dollars to finding these creative new ways of doing things, like self-generated primary power via nat gas, like SMRs, like adaptive reuse, and deploying small scale data centers. So the next 5 years, we'll see this amazing rate of innovation and change in the way we do things to accommodate this completely new shift in tech that AI has brought us.